I think of the Tower of Hanoi problem, I don't think about a series of moves made, but I think of a master plan on what I want to do. And then I divide that master plan into several sub-plans that helps me achieve the goal I'm looking for. What I mean by this is if I look at the Tower of Hanoi problem and I see the 3 stacks, I know my goal is to move the entire tower from stack 0 to stack 2. And in doing that, I know the only way to move this big block is to first move the 3 blocks on top of it here to a spare stack, and then move the big final block to the target destination. And I'm going to use that logic and actually draw out the 2 different pieces of my plan. So here the first piece is to move the entire top part of the stack to stack 1 and move that bottom element to stack 2. And I need to do stack 1 first, or step 1 first, and then I can do step 2 once I have the sub tower moved off from on top of the tower. There's a third step that eventually, once I get the base moved over, I need to move over the sub tower from where it was on stack 1 to stack 2. So at each step, I'm going to take off everything but the bottom layer, move it to a spare spot, then move the bottom layer. So what we know is we need to accomplish step 1 before we can do step 2. We have to remove that entire sub tower that's on top of the bottom cube to our spare spot. Let's think about how we might plan that. To do that, I can just ignore everything to do with step 2, because we know we need to accomplish step 1 first, and we know that whatever is hidden down here is going to be larger than everything above it. So we can, without any concern, put our smaller blocks on top of anything that might be underneath and hidden in this gray area. So my job here is now to move a tower of height 3 over to this middle stack. Well, this looks like another version of the same problem. I need to take these 2 cubes and move it to my spare stack over here so I can move this 1 cube over to my middle stack. And that's exactly what my plan is here. And then as a third step, move it back together. So let's again just plan on how we might do this first part of moving the stack of 2. Ignoring everything in the bottom 2 layers now, we know everything in those bottom 2 layers is larger than what we're seeing above, so we can look at this problem as only solving moving a stack of 2 things. Well, moving a stack of 2 things should be relatively simple. I move the top layer to the spare spot, I move the purple cube all the way to its intended destination, and for completion's sake, why don't we even just ignore that bottom layer again? And here, I just need to move 1 cube, 1 space. This problem I know how to do. This is a simple move operation. So since I know how to make this move operation, I can just do it. There's nothing on top. There's nothing constraining me. Now I finally made my first move. I did a whole bunch of planning, but at this point, I've made my move. And now I can start unwinding our tower. So remember, our original plan was now to move the purple block to its intended target destination only once we removed what's on top of it. We've removed what's on top of it, we can make that movement. And the move made 0 to 2. The very last thing was that third step that we need to move our sub tower on top of our tower to make it the final destination. And that third step we can go ahead and accomplish by simply making a single move, something we know how to do. And now we have our third move. So now we've accomplished the goal of moving this tower of 2 from its initial location to its location that is in a spot that we can start to move our next cube that we've hidden down here. Revealing the next layer, we now have the orange cube that we simply need to move over to the center stack. Because there's nothing on top of it, we can do a simple move. And here we now have the orange cube that's in the correct location. Remember, the next step, though, is to go ahead and move this sub tower on top of the orange cube, so then we can move the blue cube from stack 0 all the way over to stack 2, which we can't do right now because stack 2 is occupied. What this means is we can uh-oh, we can't just move this directly. This is a series of 2 cubes. This is a tower in itself. But we can kind of repeat this process again in saying that, okay, a tower of 2 cubes, everything down here is larger. We don't care about where it's located at. We just know it's larger. And we can divide that problem up. We can completely wind it, unroll it, re-whirl it. And we do this process recursively until many moves later, we finally get the final solution, that we move the entire tower over just as we originally planned. So I think of this as an extremely intuitive solution. The idea that we're going to slowly ignore part of the tower, making only small moves that we know exactly how to do. And by following a pattern, we can eventually get it there. We can eventually get a solution. But let's look at this more mathematically. Let's analyze exactly what's being planned. So instead of looking at the moves that we actually made, let's keep track of the moves we've actually planned. So our plan is to move the source stack. So I'm going to label the stack as a source and the target. The goal here is I want to move everything from the source to the target. To move a stack of 4 blocks from the source to the target required 3 steps. The first step was to remove everything but the 0th block, so blocks 1, 2, and 3, to the spare tile. So we want to move this tower to the spare tile. The second thing was to move that bottom block from the source to the target. And then that third step was we have all of these blocks here on the spare, and we need to move those spare blocks onto the target. The combination of these 3 steps makes it so that we can move the entire tower from the source to the target. Of course, each of these steps themselves may require a number of sub-steps. Following the logic we described earlier, we can ignore that very bottom layer and now just focus on this subtower of 3 blocks. Notice that here in this subtower of 3 blocks, our target for these 3 blocks is different than the target for all 4 blocks. So we wanted to put the 3 blocks into the middle stack so that that bottom tile can move to the far stack. So what happens at each time we add a blinder on top of our stacks, we're swapping the target and the spare. Which stack we call the target and which stack we call the spare is entirely dependent on kind of what round or what height we're on. And we know that the process of converting the stack of 3 from a source to the target involves 3 different substeps: moving this tower of 2 over to the spare, moving this last element to the target, and then moving this tower of 2 back on top of the target. We see these steps outlined here. And of course, those steps then require a tower of 2 to move, and the tower of 2 can move through 3 individual steps. And this process goes on and on and on and on, but we have a pattern to do it. And this pattern repeats the exact same thing every time we go through these steps. What is that pattern? Well, if we look at the very first iteration of that pattern, the moves that we planned to move all of the blocks, so 0 through 3, to the target. In doing that, we need to move blocks 1 through 3, so everything from the start plus 1 to the spare. We need to move the starting location to the target, and then we need to move whatever we move from the source over to the target. So if we take out these numbers and put in variables, we can say that the move to move a source from the start block to an end block to the target requires going from this one past the start to the end. So this is corresponding from moving from 0 to 3. We need to move from 0 plus 1, or 1 to 3 to the spare. Then we need to move 0 to the target. And then we need to move that 1 to 3 to the target. So what we have is we have code that describes an algorithm that we intuited on how we might solve this problem. And this is all we need to know, is we just simply need to plan a move from start to end, and each movement that does that is going to require 3 sub-moves that's going to help us make that move. So here is the game move function, and this move function is going to take in a lot of parameters because we're going to need a lot of information to run our algorithm. As we discussed, we need a start point and an end point. So the starting point initially will be 0, the ending point will initially be 3, and as we move up and down the tower, those start and end points are going to change depending on how our subcalls are made. We also need to know what our 3 stacks are called. So we're going to store a reference to our source, a reference to our target stack, and a reference to our spare stack. And then I've included a 6th variable called depth. This is just going to keep track of how deep we are in the recursion. How many steps underneath the top step have we made? So on line 50, we see out the planning a depth at a certain depth, incrementing depth along the way. So we're planning a move at a certain depth, and the move is going to be equal to whatever move we're about to plan. We output a bunch of stuff that you're going to see on the console. On line 52, the one thing I do want to check before just going into our move pattern is to see if we're moving only 1 cube. And we can see if we're only moving 1 cube by seeing if the start and the end are the same. So if we're moving 1 to 1, that means we're only moving cube 1 because our start and our end is the exact same value. So if our start and our end are the exact same value, if that's the only cube in the range that we want to move, then we can just move the cube directly. So move cube is simply going to move a cube from the source to the target. Then we'll print out the state of the game. Otherwise, we want to follow our pattern we developed. Remember, the pattern we developed says start +1 to end, and we're going to move the source, and we're going to swap target and spare. So notice that we say source, target, spare here at the top. And the bottom we say source, spare, target, swapping the spare and the target. And we go ahead and send depth forward. Second step, so this corresponds to step 1. Step 2 was we move from start to start. So we remove only the initial element. So that element 0 from source to target to spare. And then our very last call, call 3, says we're going to take start +1 to end. And the source of this is actually our spare. So we remember, we put in line 1, we put all of the cubes that were on our source onto the spare. So in step 3, we need to take all the cubes in the spare and move it to the target using the source, the original spot that these cubes came from, as our new spare node. So let's see this program actually work and explore how this program looks when it runs. Going into CPP Tower Solution 2, I'm going to run make. We run /main. And we see the program runs and runs and runs. But at the very end, we see the final game state is 4, 3, 2, 1. That's awesome. So the initial game state here is 4, 3, 2, 1. And then we see there's several planning moves. We plan to move 0 through 3 from a stack at a certain memory address to another stack at another memory address. So from stack 70 to stack A0 using 88 as a spare. We go deeper and we say we want to plan to move 1 to 3 from the source stack, the 70 stack, to the spare stack to 88. So notice these swap back and forth, just as we expected. Then 2 to 3 and 3 to 3. Here now at the planning depth of 3, we're removing the element at height 3 to another element at height 3. We see that only here do we make our first move. We've planned 4 moves, and only then do we make a move, moving this element that was on the 0 stack to the middle stack. So 1 is now on the middle stack. And you can see this process goes on and on and on with lots of planning moves at certain points. Moves when it gets down to the point where we have just a single element in its range. And then here at the final game state, we find that we do successfully move that through. I built this Tower of Hanoi solution to be pretty general, so I hope you play around with it and see how this program works together. You can add more cubes, add more stacks, and as long as you make sure the program knows about exactly what you've added by making sure that you added it to the appropriate data structure, you can then run this program and see exactly how this works when you have more cubes, more stacks, or any of the above. Play around with it, and then I'll see you in the next video.